The first 5 numbers in a pattern of numbers are given in the table below. So we have our term numbers and then the actual numbers in our pattern. So U1 or term 1 is 13, U2 or term 2 is 15, U3 or term 3 is 19, U4 or term 4 is 25, U5 or term 5 is 33. Then we have questions A, B and C. This table here is attached to question C to work out. So press pause and have a go at them, and when you're ready for the solutions, press play. So part A1. Follow the pattern in the table above to write the next 3 numbers into the table. So we need to figure out what term 6 is, term 7 and term 8. So if we have a look at 13 and 15, the first 2 terms, we can see there's a difference of 2 because 13 plus 2 is 15. Then 15 and 19, well, the difference is 4 because 15 plus 4 is 19. Then 19 plus 6 is 25. 25 plus 6 is 33. So hopefully you can start to see a pattern forming. So first we added 2, then we added 4, then we added 6, then we added 8. Next we're going to add 10. So 33 plus 10 is 43. Then we're going to add 12. 43 plus 12 is 55. And then we're going to add 14. 55 plus 14 is 69. So term 6 or U6 is 43. Term 7 or U7 is 55. Term 8 or U8 is 69. Part 2. Use the data in the table to show that the pattern is quadratic. So the red numbers here we would call the first difference. We found the difference between each of the terms. The difference between 13 and 15 was 2. The difference between 15 and 19 was 4, and so on. So in red we have our first difference. So if we want to check if the pattern is quadratic, then we need to have a look at the second difference, or the difference between the differences. So the difference between 2 and 4 is plus 2, because 2 plus 2 is 4. The difference between 4 and 6 is also 2. The difference between 6 and 8 is 2. The difference between 8 and 10 is 2. The difference between 10 and 12 is 2. And the difference between 12 and 14 is 2. So we can see that this number is the same, it's constant. We have plus 2 each time. So since the second difference is the same, it is therefore quadratic. Part B. UN, or Tn, equals n squared plus bn plus c, where b and c are elements of the integer set. So integers are positive or negative whole numbers. So b and c are positive or negative whole numbers. So whatever this b is and whatever this c is, it's a positive or negative whole number. Find the value of b and the value of c. So we need to figure out what b and c is. So we're going to use term 1, which is equal to 13, and term 2, which is equal to 15. We're going to use these, and we're going to set up 2 equations, and we're going to solve them simultaneously to find b and to find c. So we're going to start with u1, or term 1, which is equal to 13. We're going to focus on this. And we're going to set up an equation in terms of b and c. So that means with b and c in it. We're going to set up an equation using u1 and 13. So we know from the question that this is our UN formula. So UN equals n squared plus bn plus c. So UN equals n squared plus bn plus c. So we are interested in U1. So we're going to swap every n for 1. So U1 is equal to 1 squared, with brackets, that's important, because we're swapping the n for 1, plus b times 1. So again, we're swapping that n for 1, plus c. So all we did was we wrote out the general formula given, and then we swapped each of the n's for 1 with brackets. And now we're going to let that equal to 13 because we know that u1 is 13. So we swap each of these n's for 1, and then we equal it to 13 because u1, or term 1, is 13. So then we just simplify. So 1 squared is 1. B times 1 is b. We bring down the plus c, and that's equal to 13. Next, we want to get the B and the C on the left, so we want to get all the letters on the left and the numbers on the right. So we need to grab hold of this 1 and bring it over the equal sign, and it becomes minus 1. Another way of looking at it is saying that we minus 1 to both sides. So we have B plus C is equal to 13 minus 1, which is 12. So here we have formed an equation in terms of B and C. So that means B and C is in our equation and there's nothing else. There's no n's. We don't want any n's now in this equation. So next we're going to do the very same thing but with U2 and 15. So we're going to swap each of these n's for 2 this time, and we're going to equal it all to 15. And then we do the same thing, we come up with an equation. So U2 is equal to 15. So again, we write out our general formula. UN equals n squared plus bn plus c. We're going to swap each of these n's for 2 with brackets. So we have 2 squared plus b times 2 plus c. And it's all equal to 15 because U2 is 15. Term 2 is 15. So then we multiply out at the brackets. So 2 squared is 4. 2 times 2 is 4. And then b times 2 is plus 2b. We bring down the c, and it's still equal to 15. So again, we want to get the letters on the left and the numbers on the right. So we grab hold of this 4, and we bring it over the equal sign, and it becomes minus 4. So we have 2b plus c equals 15 take away 4, and 15 take away 4 is 11. So we have our letters on the left. I know there's a 2 stuck onto that b, but we can't just break that up. And we have our constant on the right, which is 11. So anything containing a letter, containing a B or a C, is on the left, and any numbers on their own, any constants, are on the right. So we have 2B plus C equals 11. So now we have a second equation in terms of B and C. That means B and C is in the equation, and we've no n's. We don't want any n's in this. So now we're going to take this equation and the one from the previous slide, and now we're going to solve them simultaneously. So now we want to solve the equation simultaneously. So we have b plus c is equal to 12. That was our first equation. And then 2b plus c is equal to 11. That was our second equation. And we want to solve, which means we want to find the b and find the c, get them on their own. So at the moment we have b plus 2b, which would give us 3b. And we have c plus c, which would give us 2c. So at the moment there's no way to cancel out the b's or cancel out the c's. And what we want is to cancel one of them out so that we can find the other. So the easiest way to do that is to change the signs of this entire line, this entire equation, and that will cancel out the c's. So if I change this entire equation to the opposite sign, then I'll have a plus c and a minus c, which I'll be able to cancel out. So I'm only changing the signs of the second equation. So I can write down the first equation again. So b plus c is equal to 12. I'll just write that down again. Now 2b becomes minus 2b, plus c becomes minus c, and 11 becomes minus 11. Now the c's will cancel. C take away c is 0, so they'll cancel out. And 1b minus 2b is minus 1b. And 12 minus 11 is 1. Now to get the b on its own, we divide by what's stuck in front of the b. So minus 1 divided by minus 1 will just give us b. We're just left with the b. And 1 divided by minus 1 is minus 1. So b is equal to minus 1. So we found b. Now we need to find c. So now we sub b into the top equation to find c. So we take this top equation, b plus c is equal to 12. So b plus c is equal to 12. And we swap that b for minus 1 with brackets around it, because we know that b is equal to minus 1. So we have minus 1 plus c is equal to 12. The minus 1 comes over the equal sign, becomes plus 12. So c is equal to 12 plus 1. So c is equal to 13. So we found the value of b, it was minus 1. And we found the value of c, it was 13. Now, if we were asked to find un, the nth term, we would sub b and c into un and simplify. Now, we weren't actually asked to do that in this question, but it is a very common question. So we had un equals n squared plus bn plus c. So that was the general equation. We found the values of b and c. So we found b to be -1 and c to be 13. So we can write this equation out again. Un equals n squared plus bn plus c. We swap the b for -1 with brackets around it. We swap the c for 13 with brackets around it, because b is -1 and c is 13. And then we simplify. So we bring down the n squared. -1 multiplied by n is -n, or -1n. And then we bring down the plus 13. So this is the actual nth term now of our pattern. And we can use this to find any term in the sequence. So un is equal to n squared minus n plus 13. And if we were to draw this out, because there's a squared, it would be U-shaped. Part C. The table below shows the first 5 terms of an arithmetic sequence. Find an expression for Tn, the nth term of the sequence, hence or otherwise find the value of T30, the 30th term. So when it says hence in a question, it means we're going to use our previous answer. So once we have Tn, we can find T30. So for Tn, there are 2 things that we need. A, the first term, which is 12. So 12 is going to be equal to A. And then D, the common difference. So to get from 12 to 14, we add 2. From 14 to 16, we add 2. From 16 to 18, we add 2. From 18 to 20, we add 2. So D, the common difference, will be 2. It's important to note that arithmetic means the first difference is the same. So we're going to write out our formula from our formula book for Tn, which is Tn equals A plus bracket n minus 1 times D. We're going to swap the A for 12 because that's the first term, and swap the D for 2 because that's the difference. Then we multiply out our brackets. So n multiplied by 2 is 2n. We just bring down the 12 in front. There's nothing to do with the 12. And minus 1 times 2 is minus 2. Then we bring down the 2n. And 12 minus 2 is 10. So Tn is equal to 2n plus 10. So we found Tn, the nth term. Now we need to find T30, the 30th term. So now sub 30 into Tn in place of the n to find T30, the 30th term. So Tn we worked out to be 2n plus 10. We swap the n for 30 with brackets around it. And 2 times 30 plus 10 is 70. So term 30, the 30th term, is 70.